How can one misplaced patch cable bring an entire factory network to a halt? The answer may be a broadcast storm. Picture a busy warehouse. One worker shouts an alert, everyone repeats it, and every repeat is repeated again. In seconds, the room is so noisy that no useful instruction can get through. Broadcasts are not the enemy. They are a normal part of Ethernet. An ARP request asks, "Who has this IP address?" A new DHCP client broadcasts to find network settings. A layer 2 switch forwards those frames through the same VLAN, except through the port they arrived on. Trouble starts when a broadcast enters a layer 2 loop. Maybe 2 switches have redundant links with no working loop prevention protocol. Maybe someone connects a patch cable to the wrong ports. Ethernet frames do not carry a TTL counter. When the frame comes back, the switch floods it again. Copies circulate, more copies are created, and traffic builds very quickly. Links fill up, switch resources are consumed, MAC addresses can flap between ports, and normal packets arrive late or disappear. In a factory, that can freeze PLC to HMI updates, interrupt remote I/O or drive communication, and delay alarms or monitoring data. Operators may lose visibility just when they need it most. A loop is the classic cause, but it is not the only one. A faulty device, an ARP or DHCP burst, or other abnormal broadcast-heavy traffic can also overwhelm a broadcast domain. So how do you keep the network stable? Start with loop prevention. STP or RSTP keeps redundant links available while blocking the extra forwarding path. Next, use VLANs to keep broadcast domains at a manageable size. If one area has a problem, the traffic does not spread across the whole plant. Add storm control on the ports where it makes sense. It can limit abnormal broadcast, multicast, or unknown unicast traffic. But it is a safety net, not a repair. The loop still needs to be found and removed. Monitoring matters too. Watch port utilization, broadcast rates, MAC flapping, and topology changes. Keep the network diagram current, and investigate sudden growth before production is affected. Broadcast traffic is necessary. What brings the network down is uncontrolled repetition. Remove the loop, contain how far the traffic can travel, and catch abnormal behavior early.